Good morning, Sean here from Mountains Garage. Today's subject is drive shafts. In the past, my experience at my local drive shaft shop has been a lot like Jerry Seinfeld and his friends trying to get soup, if you know what I'm talking about. Nowadays, there's more choices and the guys are more open-minded. I understand their perspective, and I also have my own. So there's a few things you need to know if you choose to have one built locally, mail order, or build it yourself, which I'm going to do here, or at least explain how, or shorten. If you choose to shorten the drive shaft, that's a different subject, and we'll also talk about that. Let's get into it. First, let's talk about the material your drive shaft is made out of. These are steel shafts laying here. It's the most inexpensive choice, which is laughable because all drive shafts are expensive. And they come in different diameters, anywhere from 2 to 6 inches. Anywhere in the 2.5 to 4 inch range is probably normal for an automobile. Aluminum shaft would be the middle choice. It's probably $400 to $600. And a light and good and strong choice. And third is carbon fiber. An excellent choice, expensive, around $1,000. And the safest choice. Let's talk about that. With steel shaft, when things go wrong, we'll come up inside the car in a big piece, and there's been accidents where it'll take your arm off or really make a mess inside the car. An aluminum shaft will break into smaller pieces, still a lot of shrapnel, and it's lighter, and it's, let's just call it, I'm using bunny ears, but less dangerous. And then carbon fiber will unwind or break into small pieces and turn to powder, and it's the safest choice, but also the most expensive. That's the way life goes. While talking about drive shaft safety, which, trust me, nobody wants to talk about safety. You're better off talking religion and politics, because it's about as popular as, well, nothing. In a door car with stock floors or hot rod or street rod, something, this is the minimum you should have within 12 inches of your front U-joint to protect yourself. That's the bare minimum. There are thousands and thousands of tube chassis cars with aluminum floors that have one of these in the front of the drive shaft, and the chassis forms another one in the back, and it's wrapped with aluminum, and all of this shaft is just waiting. Your arm's about right here, and your hand, the shift is usually right here. I mean, that's what you're waiting for. It's happened. We were so close a few years ago. There was enough accidents, because the entire NHRA rulebook and rulebooks in general are usually written in blood, that they were going to mandate, and all fast cars have to have this already, the first 12 inches of the drive shaft have to have a steel tunnel, so this would actually have a tunnel inside it, removable from the car, over the entire front yoke area. On the rear end and the back 6 inches has to be covered, and then typically the chassis itself would form at least one more, just the way it's designed, to try to keep the shaft inside the car. Depending on your manufacturer of your vehicle, there are hundreds of U-joint choices. I made it easy. I don't care what brand it is. If I'm putting one dime into a drive shaft, it's going to have a 1350 series Spicer U-joint and matching yokes and rear end yokes. So everything is 1350 series. Up until the last few years, a 1350 U-joint will take you well into the 6-second range, quarter mile, no problem. Now with cars making 3,000-4,000 horsepower, the 1480 Spicer U-joint, which is absolutely huge, is the only other U-joint series drive shaft that will earn an SFI tag. And that SFI tag brings us back around to, are you going to build your own drive shaft with pieces? Are you going to have your local shop build one, which these two are? One's actually factory Chevy, one's an aftermarket, somebody built local. Or call one of the many chassis shops, most of them located in the Midwest, and for a very reasonable price, they'll sell you the shaft. You don't have to have U-joints and a yoke. They will sell you a shaft. It's all balanced. Absolutely no speed limit on it. You can go as fast as your heart desires. and bring it home, put your yoke and your U-joints on it, and be pretty happy. Again, this actually costs less than local. Local, they typically want, and I understand their perspective, like I said in the beginning of the video, because they want a success. They don't want you coming back. They typically sell you a mild steel shaft, MIG welded, and they want to at least have your yoke. If it's got one scratch on it, they want to sell you a new one. They want to sell you new U-joints. They want to balance the whole thing as an assembly. Now, I believe your U-joints and your yoke are serviceable items. You should be able to change those and not have to rebalance your shaft. No problem in a 200 plus mile an hour drive shaft that's chrome moly, TIG welded. It's a beautiful piece. And then that third choice is you're going to build it yourself. I buy just a strange engineering chrome moly. I buy splicer ends. And up until a certain point, which you have to draw that line in the sand, what you think is right for you. I'm pretty confident that I can assemble this shaft, TIG weld it. You know, I'm not capable of balancing it, but a lot of shafts like this one here is built locally. There's not a weight on it. So you don't know till you get it all done. And if you did have a vibration, you could, one, take it to someplace and have it balanced locally. I mean, they do that. Two, you can mess around with hose clamps and try to get the vibration yourself. Third, the truth is probably you're never going to feel a thing unless you see, you know, suddenly you're wiping bushings out of the back of your transmission or your pinion seal's leaking. Probably never going to notice a difference. Again, it's your choice. Did you ever notice? We balance engines religiously. If you do any change in an engine, you're supposed to rebalance it. Not a lot of talk about transmissions. I'm sure NASCAR shops, and this is probably some secret, you know, high-tech stuff that's going on with $1 million budgets that they're balancing transmissions, but it's not something we normally talk about. I can put gears, change gears, do anything I want in the transmission, automatic or standard. And we don't worry about balancing, I guess. Drive shafts, we're always talking about balancing a drive shaft, and they will cause problems. Rear end parts. I buy axles and stuff like that, have them made. A lot of times they're as big as a drive shaft. We don't talk about balancing those. Or any rear end component. I can put aluminum spool, I can put a steel spool, I can lightweight ring and pinion, heavy ring and pinion. Nobody talks about balancing inside a rear end. Ever. Period. And I'm sure, again, if you've got a expensive race team with $1 million budgets, they probably do worry about that stuff. But your average guy does not. But way out on the rear end, we worry about the wheels and tires, and we balance those. It's a funny world. Engines, drive shafts, and tires are really the only thing we worry about balance on. Think about it. Drive shaft measurement. Lots of different ways to do it. There's only one that I go by. I start with my transmission yoke, and I want it 3/4 of the way into the transmission. I want to make sure it'll go in all the way, and then I want to pull it back about 1/4 of its travel. This is with the car on the ground, the rear end's up where it belongs in the car. And I want the yoke of the yoke inside the transmission about 3/4 of its length. So it's about yay long. Envision 3/4 of that inside. I want to measure center to center of the U-joint. I don't care any other distance. I don't even consider it. And I use that to figure out whether I'm shortening a shaft or building one. It's pretty simple. If I put the rear end yoke, typically is already showing you half this distance. Typically they've got half a circle. So I measure that face up to here, and I got my center. It's that easy. Now that I know what my required center U-joint to center U-joint distance is, whether I'm shortening a drive shaft or building a new one, this is my weapon of choice. It provides the most accurate cuts. I can cut that in the bandsaw, but I don't guarantee it's going to be straight. This has to pretty much cut straight. It makes a nice finished straight cut. These, I finish the end of the cut drive shaft, so those will slide in. They slide in to the weld mark right there. Drive shaft phase. Each yoke needs to be on the same plane, if you will. If you put a level on there, it'd be level. That one needs to be level too. I pretty much will hook them down to the bench and go ahead and tack either end. So now I've got a drive shaft that's tacked. I need to make sure it doesn't have excessive run out. My phase isn't going to change. If I'm shortening a shaft, before I cut the drive shaft, I use a metal scribe, and I scribe from the center here all the way down the shaft past where I need to cut. Don't use a Sharpie because it'll end up getting washed off, and then you don't know how to phase it properly. It's a lot easier if you put the scribe back where it was. If you're shortening the shaft, building a new one, I just put it on a flat surface and it's phased. I go ahead and tack it together, and then next we need to check run out before we fully weld it. 2 ways to do that. If you have a lathe large enough to accommodate your shaft, you can put your shaft that you've tacked together. I typically would go 4 places around it. I would assemble a U-joint onto the yoke, put the yoke in the chuck, and I'd run it out through the steady rest. And I'm just going to turn it by hand. I'm going to put the dial indicator up against it, and I'm going to see how much run out I have. Up to probably 1 or 2 thousandths is normal. Well, closer to 0, obviously better. This is great if you have a lathe long enough to accommodate a pretty decent shaft. If you don't, and most don't, you can put it back in the car, find a way to attach your dial indicator onto something that's magnetic, find something that's close to it, and easily accomplish the same thing, probably even better than this, because you don't have to mess around with the steady rest, getting the shaft centered and everything else. So you just stick it back in the car that it's going in. 1, you're going to find out if it actually fits before you weld it. And 2, you can go ahead and check run out. If your run out is incorrect, you need to knock it around with a hammer or remove a burr. I'm going to tell you, pretty much when you got brand new stuff, it goes together pretty nice and there's no run out. Now you're at the point of welding. Again, my choice is going to be a nice small TIG weld. It's going to affect the balance less than a big MIG weld with a knot at the end of it like these have. But use what you got, and it'll probably be okay. My hillbilly balancing method, if I'm shortening this shaft and the weight's that big, and let's say I cut 1/4 of the shaft off, I'm going to go ahead and just cut 1/4 of that weight off there. And I'm probably never going to have a problem. I've done this I don't know how many times. I'm always changing transmissions that are different lengths, engine swapping at mostly LS swapping vehicles, and seldom have a problem. Okay, that pretty much sums up the wonderful world of drive shafts as I know it. There's a lot more information out there. I'm just one guy giving you my opinion. I received some positive criticism the other day from a friend of mine about my first video, and he wasn't telling me anything I didn't already know. For the first video, I talked to the camera for 30 minutes straight. I've never talked to anybody or anything for 30 minutes straight, even myself. Editing was not a joy, and it came out, it's my first video. I'm not saying they're getting any better, but I did figure out I film short segments while the subject matter is in front of me, and then I watch it, and if it's not any good, I do it again until it's an acceptable level of whatever. But like and subscribe. Thanks for watching. I'm going to keep doing them, and thank you.